June 2015. 500,000 teenagers walk out of a maths exam, and within the hour an entire country is arguing about sweets. Impossible, they called it. Unfair. A trick question. It is none of those three things, I promise you. But the reason so many clever people froze solid is genuinely worth knowing, because this question does not ask what everybody assumed it asks.
The Problem That Broke the Internet. Episode 1. Hannah's Sweets. Here it is, word for word, exactly as it sat on the exam paper. There are N sweets in a bag. 6 of them are orange, and the rest are yellow. Hannah takes a sweet at random, and she eats it. Then she takes another one at random, and she eats that one too. The probability that both of those sweets are orange is 1/3. And now the instruction itself. Show that n squared minus n minus 90 equals 0. Read that last line one more time. It never says, find the probability. It never says, how many sweets. It hands you the finish line and asks you to walk there. In that exam hall, thousands of people read those words and started hunting for a number. There was never a number to hunt for, and the clock just kept going.
Right! Let us do the one thing that exam hall did not do. Let us start from what we actually know and write it down. 6 oranges. A bag holding N sweets altogether. So the chance the very first sweet she grabs is orange? 6 over N. Now the sneaky bit. And it is the entire reason the story bothers to tell you she eats it. That sweet is gone. It is not coming back. So on the second grab, there are only 5 oranges left, sitting in a bag of N minus 1. 5 over N minus 1.
Both orange means the first one and the second one. Both things, one after the other, in the same run of events. And in probability, the word and means multiply. Take a fraction of a fraction, and multiplying is exactly how you do it. So multiply the 2 chances together and set the whole thing equal to the 1/3 the question already handed you. That single line is the whole problem. Solved. Everything after this is algebra, and algebra is only tidying up.
Now watch me be extremely boring, entirely on purpose. Boring is how you stop making mistakes. Multiply the tops together. 6 times 5 is 30. Multiply the bottoms together. N times n minus 1. And n times n minus 1 is n squared minus n. Multiply those brackets out now, because the answer we are marching towards has no brackets left in it. Cross-multiply. 30 times 3 is 90. So 90 equals n squared minus n. Drag the 90 across to join the others, and there it sits. N squared minus n minus 90 equals 0. Marvelous.
Here is the single most common wrong answer in the whole country that morning, and it is worth staring at for a second. 6 over n times 5 over n. The same bottom, twice. Look at what that person has done. They remembered a sweet was eaten, but only on the top. But when a sweet leaves the bag, it leaves the top and the bottom. The bag genuinely has 1 fewer sweet in it now. 5 over n minus 1. 1 fewer orange on top, 1 fewer sweet underneath. Change both every single time.
The exam stopped right there. Full marks. Pens down, off you go. But you and I both want to know how many sweets were actually in that bag. So let us finish it. I need two numbers that multiply to make minus 90 and add to make minus 1, minus 10 and plus 9. Which means n equals 10, or n equals minus 9. And minus 9 is nonsense. No one has ever carried a bag with minus 9 sweets in it. Cross that one straight out. 10 sweets. Check it yourself. 6 over 10 times 5 over 9 is 30 over 90, and 30 over 90 is exactly 1/3.
So, the question the whole internet was really asking that week, was it a fair thing to put in front of a 16-year-old? Not unfair, unfamiliar. Every single step in it is ordinary classroom maths, and none of them are hard on their own. What was new was the shape of the instruction. Show, that means the destination is already printed on your ticket, and the journey is the part they are marking. 3 moves, and they work on every question of this kind. Write the first chance. Write the second chance. Remembering what left the bag. Multiply, then tidy. Your turn, and this one is genuinely the same question, wearing a different coat. 4 red counters sit in a bag of n. You take 2, and you do not put them back. The probability both are red is 1/6. Show that n squared minus n minus 72 equals 0. Put your answer in the comments. And next time on this channel, the division problem that has been starting arguments online for 15 years. 2 answers. Both camps certain. Only one of them is really right.